So today you are going to study base classification. So it is in unit 4. So let us understand first what is this base classifier. So it is statistical classification technique based on Bayes theorem. So Bayes probability theorem is used for classification in this classifier, and it is simplest supervised learning. It is type of supervised learning. So along with input data, we have to provide labels also. That means output also should be given to algorithm along with the data. So the main advantage of this Bayes classifier is it is fast, accurate and reliable algorithm. It is simple also, and this algorithm is having high accuracy and speed on large database. So generally when data set is very large, this Bayes classifier is used. In this classifier, it is assumed that the particular feature in the class is independent of other features. That means attributes are independent. That is assumed in this Bayes classifier. So for example, one example is given there. Suppose bank has to give a loan to any person, then it will check the attributes like that person income, previous loan condition, transaction history, age of the person, location. So it will check a different attributes for the sanctioning of loan. So these attributes are interdependent, they are depend on each other. But in Bayes classifier, these attributes are considered as a independent attributes, and that's why it is called as a naive Bayes classifier. And this assumption is called as conditional independent. So they have considered these attributes as a independent, but these are conditional independent. Now this Bayes theorem is used to find, Bayes theorem is used for classification. So here the formula is written, the P is the probability. So just go through this. So PhD, the probability of H over D, that is written here, the probability of hypothesis H. Hypothesis means we are assuming something and then we are checking whether that is true or not. So the hypothesis is H, the probability of hypothesis H given the data D. So D is the data, and this probability is known as posterior probability. So this we want to find whether our hypothesis is true or not. In example, it will be more clear. The second parameter used here, the probability of D over H. Again, H is hypothesis. So here probability of D over H is written. The probability of data D given that the hypothesis was. So here we are finding the probability of data D over hypothesis H multiplied by P of H. So P of H is probability of hypothesis H being true regardless of data. So this is known as prior probability of H and divided by P of D. So P of D is probability of data regardless of hypothesis, and this is again known as prior probability. So this is the Bayes theorem. Using this Bayes theorem, the classification technique is used. So this formula we have to use for classification. Now how does Bayes classification work? So for that we are going to consider this example of playing any sport. For example, suppose tennis. So we have already discussed about this example in decision tree. The same example we'll use here. This training data is suppose given as per the day. The weather conditions are written here. The outlook is sunny, overcast, means cloudy, or it is raining. So like that, these conditions are given for the particular days. The temperature is also mentioned for these days, may be hot, mild, cool. So three types of temperatures are there for each day. Then humidity, whether it is high or normal. Then wind condition is given, that is weak or strong, and this is the output. So along with this input, output is also provided here because it is supervised learning. So if these four conditions are satisfied, then the user cannot play tennis. That is no. If these four conditions are satisfied, user can play a tennis. Like that, 14 conditions are uh, given here. Then 14 days data is given here. So total number of rows are 14, and this data is used for training, and these are the output labels for each of this row. So using this table, we'll check how base classifier is used for classifying the input data. So here it is written, given an example of weather condition and playing sport, you need to calculate the probability of playing sports, whether you can play a sport or you cannot play a sport. Now you need to classify whether player will play or not based on the weather condition. Now we'll see how this example is used. So in case of single feature, if you consider only one attribute from that given table, you may consider outlook, you can consider temperature, humidity, or wind. One single attribute, if you consider, then how this base classifier will classify this input. So first step is calculate the prior probability. We have to use that Bayes theorem formula to classify this atom. So first thing is calculate the prior probabilities, that is probability of data and probability of hypothesis. In our case, the hypothesis can be yes or it can be no. If you want to find the probability that yes, player can play a sport, then we say that S is our hypothesis. We have assumed that the user can play a sport. If you want to find the probability that user is not able to play this sport, then hypothesis is no. We are assuming first that user cannot play a sport. So this hypothesis will assume, and according to that, we'll find this probability. So first you have to find this prior probability, then find likelihood probability with each attribute for each class. So for an example, we'll consider only one attribute and we'll find the likelihood probability. Put these values in base formula just now we have seen, and calculate posterior probability. We are interested in finding the posterior probability. After this calculation, see which class has a higher probability, given the input belong to the higher probability class. So after finding this probability, we have to check for which probability is higher, and we'll consider that as a output. So let us go through the example. The one attribute only is written here, that is the weather condition, whether it is sunny. So only one attribute is taken from that table. Training example, weather can be sunny, it can be overcast, or it can be rainy. So three conditions are mentioned in weather condition. So here we are finding only for one attribute. So here frequency table is written. So for this weather attributes, weather can be overcast, that is cloudy, it can be sunny, or it can be rainy. Now we'll check the output label for this weather condition. No, it can be no, or it can be yes. So check for overcast. The overcast, then condition is yes. If weather is overcast, condition is yes. If weather is overcast, condition is yes. Again here when weather is overcast, condition is yes. So four conditions are there related to overcast and all conditions are yes. So in frequency table what we can write, the no is 0, there is no condition for overcast. Means if we can say that if weather is overcast just by seeing, observing this data, then you can play a sport. But we have to use the base theorem to classify this. So no is 0, S is 4. For sunny you can check, no is 2. For these two rows the output is no. And for other this thing, for 3 it is no. So just check this. Fine. And total here no are 5 and S are 9. So total no are 5 and total S are 9. Out of 14, just we'll assume that here, out of 14, total 14 rows are there. The total rows for S are 9 and total rows for no are 5. Now this base theorem, using this base theorem, we'll find the probability. So this formula you have to remember. So the same thing is written here. Just how you'll write this formula for this particular overcast condition. So here whether four attributes are there, or three attributes are there for weather, overcast, sunny and rainy. We'll find this base theorem for overcast condition here. So if it is overcast, the player can play sport or not. That we'll find from the weather. So how we'll write this formula for overcast condition? So this probability, posterior probability, we want to find. S is our hypothesis. We are going to find whether player can play or not. S or no, not. So S is our attribute in this case. So probability of S over overcast. So this is this we are going to find the probability of hypothesis H. Here we are assuming the output as S given the data D. We are finding only for overcast. That is equal to P over cos S, that is called a likelihood. This is P D over H, the probability of data D, given that hypothesis H was true. And these are the prior probability P of S, that is the probability of hypothesis H being true, and this is P of overcast, the probability of data. So this for probability of S and probability of P, we have to consider all attributes of weather. So we'll see how to find this probability. Same column is shown here. So we want to find this probability and this formula we have written. Now first we'll find the prior probabilities. These are probability of S and probability of overcast. So we want to find if weather is overcast, the player can play or not. So the probability of overcast. So four attributes are there, four rows are there for overcast condition. So and total rows are 14. So for probability of being overcast will be 4 divided by 14, that is 0.29. So out of this 14, the 4 rows are for overcast. So overcast condition is 4 times. So the probability of overcast you can find like 4 divided by 14, that is 0.29. Now probability of S. We are considering this whole column now for calculating prior probability. So S, how many S are there that you have to count? 3, 4, 5, 6, 7, 8 and 9. So 9 S are there. So probability of S will be 9 divided by 14, that is 0.64. So this is overall probability from the given attribute column. So 4 times overcast appears in this column. So we are dividing this 4 by total 14, so 0.29. 9 times S is there, so 9 divided by 14, 0.64. These are the prior probability. Now we want to find this probability of overcast over S. So probability of overcast over S, that means how many times S is there for overcast. So here there are 4 columns for overcast, and all of this four rows are there for overcast, and for all of these rows the output is S. So S is 4 times for overcast. So we'll divide this 4 by 9 because total number of S are 9. So don't consider here 14. We are calculating this probability of overcast over S. So total number of S are 9, and for overcast total S are 4. So you will get this probability as 0.44. Now we want to find the final probability whether user can play the sport or not. So for that, as per our formula, we'll multiply this 0.44, this is called a likelihood probability, into 0.64, that is that probability we have computed, that is P of S, and divided by P of D, that is P of overcast. So P of S divided by P of overcast. So we get this probability of playing a sport if weather is overcast as 0.98. So it is higher, so we can decide the player can play a sport because probability is higher. This is for S condition. We have assumed that, yes, first we have assumed that player can play a cricket. That's why we are calculating probability over hypothesis S. Similarly, you can find or calculate the probability if hypothesis is no. So you can calculate it for S, you can calculate it for no, and then you can decide whether player can play cricket or not as per the final probability. So same formula is written here, only in this case hypothesis is no. So hypothesis no over overcast is equal to this probability of overcast for no, P no and P overcast. Now we'll find this probability of overcast, that will be same as previous case. 4 rows are there out of 14 for overcast. So this probability is 0.29. The probability of no in overall this data, for overall data of weather condition. So 5 are there for no, 5 columns are there, rows are there for no. So 2, 3, 4 and 5. Total 5 times no is there. So 5 by total 14 will calculate the probability of no. Now calculate the posterior probability. For that, first we have to find this likelihood, that is P overcast over no. So for overcast, there is no row for no. We have seen that for all these 4 rows, the output is S. So no is 0 for overcast. So 0 divided by total 9 are there, 9 nodes may be there. So you will get here 0. Now put this formula, uh, put these values in this formula. So 0 multiplied by this is 0.36 divided by 2.29. So final answer is 0. So here probability is 0. Just by observing also, we can say that probability of no is 0 because there is no row related to overcast which gives the output 0. So finally what you have to check, the probability of S class is higher than the probability of no. So you can determine here if the weather is overcast, then player will play the sport. So if from this probability you have to decide whether a player can play sport or not when weather is overcast. So independently we have considered only one attribute, that is weather, and you have computed probability for S condition or and no condition, and from that we have decided the probability of S condition is higher than the no condition, so the user or the player can play sport when weather is overcast. So this is for single attribute. This is sufficient. So try to remember this formula, and then from the given table you can easily compute this. In exam, if question is asked, you can consider only 4 or 5 rows of any example and you can find this probability. Now this is the condition when we are considering only one column, one attribute. Now suppose you want to combine number of attributes together. So we want to calculate the probability of playing when the weather is overcast and temperature is mild. So in that case, we can write a probability S over weather is overcast and temperature is mild. So we are considering two attributes and two conditions, weather overcast and temperature mild. So the formula can be written as P weather overcast, temperature is mild over S into P of S. Remember that here dividing the probability which we have used in previous formula, that is P of data, is not used. Here just multiplication factor is used if you are considering more than one attribute. So weather is equal to overcast, temperature is mild, and S and P of S. Now how to find this factor? P weather is equal to overcast, temperature is mild over S, that is computed using this formula P overcast, probability of overcast over S multiplied by probability of mild over S. So to find this probability we have to use this formula. So here only two columns I have shown, the outlook and temperature. Out of this, we are interested in overcast and the mild temperature. And with these two attributes, if outlook is overcast and temperature is mild, we want to check whether player can play tennis or not. So we'll calculate this prior probability. It will be same for all attributes and all condition. So out of 14 rows, 9 rows are S. So you'll get this value of probability. To calculate posterior probability, we have to calculate first this probability of P or overcast over S, mild over S. So in overcast, we know that S conditions are 4 and there are 9 total S conditions. So probability is 0.44. For mild, the 4 conditions are S out of 9 S conditions. So probability is again 0.44. So we'll substitute these values to find this probability. So 0.44 multiplied by 0.44, you'll get this value 0.1936, and the final formula for finding this probability will be 0.1936, this value multiplied by 0.64, this probability of S. So you will get 0.124. So this is our final probability if hypothesis is S. In similar way, you can find the probability if hypothesis is no. And then you can check the value of probability for which hypothesis value of probability is higher, for S or no. If it is higher for S condition, it indicates that player can play a sport. If it is for no, higher is for no, then you can take a decision that player now cannot play sport.